Welcome to our presentation about Silo Manufacturing Corporation discussed in case study 1. Here we discuss about the strategies, cost management strategies, and the challenges faced by the management resolving those issues. There are total 8 questions given in case study, and we'll discuss the questions below. Uh, we got some information about inputs we needed, like annual demand, ordering cost per unit, carrying cost per unit, and inventory cost per unit, as well as some delivery lead times. While going to the question 1, we'll discuss about the cost difference between Ferguson's policy as well as Patrachalski's policy, where they will debate about the number of cases to be ordered. Where Ferguson's proposal to order 4 cases and Petrochalski's proposal to order 32 cases. We are using total cost formulas where we combine the carrying cost and annual ordering cost. Surprisingly, while doing both the total cost, both policies would give us a same total cost annually. Because if we reduce the number of units ordered, the ordering cost would be increased, and if we increase the number of units ordered, then the carrying cost would increase. So surprisingly, both the policies gives us total same cost. So here there is an indifference point. And while going to the question number 2, we will discuss about the Martin's recommendations using EOQ. EOQ is economic ordering quantity which will balance perfectly the holding cost and ordering cost annually, and it will give us an optimum point where the number of units to be ordered without any loss or increase in cost. So here we will use the formula of EOQ, and we know that the orders must be placed in whole cases only, that is 15 units per case. Uh, while substituting the values in the formula, we will get 170 units as a EOQ, and while dividing by 15 units per case, we might order 11 or 12 cases based on the rounding policies. So question number 3, before question number 3, we'll discuss the box given to us, and here we got total annual cost of both Ferguson and Petrachalski, where they both of the costs are equal. And annual ordering cost as well as ordering quantity are adjusted based upon the number of units per case. And going to the next question number 3, we'll discuss about the interesting rounding up policy. How does the rounding will affect the EOQ to the whole case will impact on the total cost. We are using formula of total cost, and while using 11 cases, we got 165 units, and the total cost will increase by 0.034%. If we use 180 units, the total cost will increase 0.168%. While rounding off, we got both the policies will get increased total cost, but a minimal amount. But in our group, we have decided that if at all we had a chance to keep more stock with a lower amount of cost, it's better to keep some stock in an arm's length while using in production. So we recommend the option number 2. And while going to the fourth question, here, if at all the goal of sales increased by 9.6%, what would be the ordering cost? It's the question. And here we are using the same EOQ formula, but the new demand is increased by 9.6% because the sales are to be increased by 9.6%. So substituting the values in the formula, we get the required ordering cost of $39.84. So if we want to increase the sales by 9.6%, the new ordering cost must be $39.84. So going to the next question, I will carry forward it to our teammate Varshita.
Yes, hello all. So from here, I'm gonna continue this presentation. In question 5, it is asking what would be the ordering cost for Davies to meet his inventory reduction if the given objectives are met. So, in the solution, when we see the new holding cost would be $32.928. So, for using the same target of EVOQ of 155 units, the ordering cost we got is $39.88. So, in conclusion, we can say that to achieve the inventory reduction objective, the required ordering cost for Davis must be 39.88 per order. Next slide, please. Yeah. So now here in question 6, additionally from question 5, we have one more objective of Peter to meet his goal reducing the average cost per unit by 5.2%. So when we look into the solution, the new carrying cost would be $106.176. So from this, the derived holding cost is $31.23. So again, for the same 155 units of EVOQ, the derived average cost is ordering cost is $39.81. So for achieving Peter's goal in respect of all other objectives, the required ordering cost must be 39.81 per order. Next slide, please. So here in question 7, we are discussing about the Peter's plan of implementing just-in-time approach to place an order. So in just-in-time, the order of quantity we took here as 1. So for 1 unit, the ordering cost we got here is $0.001667. So to implement a JIT system, where to implement a JIT system where only 1 unit is ordered at a time, the required ordering cost must be 0.00167 per order, which is highly impractical. So it confirms that JIT would only be feasible if the cost to place an order is nearly zero, making it unrealistic under typical business conditions. Next slide, please. So here in question 8, so here in question 8, it is asking us about any 3 recommendations to reduce ordering costs. So the 3 recommendations would be, first one, automate procurement, second one, bulk as shipping agreements, and third one would be uh, like vendor management inventory. We can say in that way too. So here in automate procurement, we can see implement AI driven systems to cut manual work, like using ERP software, auto generating orders. And then when we look into the second one, for example, we can say we can use work with the suppliers to lower the pre-processing costs. And here in the third one, we can like vendor management inventory is like let suppliers manage stock levels, shifting order responsibilities to them. With this, I conclude that in our presentation, we have discussed overall SMC's path to improve the efficiency by balancing the departmental goals and leveraging EVOQ so that the silos can reduce cost and maximize the wealth. Thank you for watching. Have a great day.